Communication practices that promote interoperability and interchangeability are key to realizing the benefits of distributed energy resources and enabling a safe, reliable, and resilient grid. Distributed energy resources, including solar, energy storage, electric vehicles, and demand response, play a key role in a modern, optimized, and integrated grid by helping utilities address issues, including the intermittency and variability of renewables, and enable future states like microgrids, transactive energy, and smart cities. The project set focuses on 4 key areas: open, interoperable distributed energy resources, product assessments, distributed energy resource architectures, and information communication systems for the aggregation, monitoring, and management of distributed energy resources. With an open, interoperable communication architecture, intelligent load, storage, and solar systems can be integrated with the existing control systems, regardless of brand, model, or technology, and without significant modification or costs. To make this a reality, EPRI will provide insight on emerging standards and industry activities, identify and address gaps in protocols and standards, and inform decision-making for both distributed energy resources and control systems. Standards are a major step for interoperability. However, experience shows that even with the most robust standards, unforeseen barriers can arise. EPRI will test products and control systems like distributed energy resource management systems in our laboratory to identify interoperability risks before issues arise in the field. The data from this testing will accelerate the availability of interoperable products by providing feedback to standards groups and manufacturers and giving utilities information on how to prevent these issues from occurring. Protocols and standards regulate how some aspects of the communication architecture are developed. However, decisions made outside the scope of these protocols and standards can have equally large business and technical impacts on the final architecture. In this project, EPRI will study the architectural, technical, and business decisions as they relate to communications technologies to identify best practices and potential barriers. The success of distributed energy resource and demand response management systems relies on a cross-functional communication architecture that supports multiple protocols, consistent data models, and logical mapping between device functionalities. EPRI will help utilities develop this architecture by evaluating different approaches, producing test tools to validate their architectures, and hosting workshops to validate interoperability. If you'd like more information, please contact EPRI.